Well, hello and welcome to today's lesson. We are going to talk about what is called a limiting reactance on that. And basically what a limiting reactant is, it's when you've got two chemicals that you want to mix together and you end up not having enough of one. I like using the example that if you had, let's say, a recipe and it called for 1 cup of sugar and 2 eggs. Okay? And I ask you, and that's for one recipe. So one recipe calls for that. And so if I ask you how many recipes could you do if I had 3 cups of sugar and I had 9 eggs? Okay? How many recipes could you do? Well, most of you could look at that and you'd say, well, I could do 3 recipes. Okay? Because 3 times the 1 cup of sugar would give me the 3 cups. And so then the question says, okay, but how many eggs are you going to use if that's the case? Well, 3 recipes with 2 eggs, that would mean I would need to use 6 eggs, right? So in this case, what we say is our sugar is our limiting because we could only make 3 recipes, okay? And I'm going to use 6 eggs. Now, if I looked at just the eggs and I didn't look at the sugar, then I would say, well, I could do 4 recipes, right? If I had any amount of sugar, I could have done 4 recipes. In that case, you see you had more. But because I have only 9 eggs and 3 cups of sugar, that's not possible. I can't do the 4 recipes. I can only do 3. I'm going to use my 6 eggs. And then what I'm going to see is because I only use 6 eggs, I have 3 extra eggs. Okay? Well, we call that our excess. Okay? And we call our sugar our limiting reactant. Okay? Because the sugar limits how many recipes I can do, and I ended up having extra eggs. We're going to do that same type of problem. We're just going to make it more difficult by using chemicals and moles and grams and not eggs and sugar. Okay, so let's get started. Okay, so the very first thing that it tells us to do is write a balanced reaction for iron chloride mixed with sodium phosphate. So that you should be able to handle. That should be the easy piece. So we've got iron chloride. And iron, it says, is a 2. We know chlorine's a 1. So I've got FeCl2. I'm going to mix it with sodium phosphate. Phosphate's PO4. And phosphate is a -3, but sodium is a +1. So I'm going to need 3 sodiums. Okay? You can read that 3 there. Okay, it is going to be a double replacement. These are aqueous solutions. I probably should have told you that. Anyway, we're just going to do a double replacement. So I'm going to get iron phosphate and sodium chloride. Now, iron phosphate, I'm going to have to check my charges. Iron is a +2, we said, and phosphate's a -3. So that should be 3 of those and 2 of those. Okay, now we need to balance our entire reaction. So I'm going to start with my phosphate. I like starting with my polyatomics. And I have 2 of them on the right, so I need 2 here. That gives me 6 sodiums. So I'm going to put a 6 there. And if I look over here, I have 3 irons, so I need 3 irons there. Now that is going to give me 6 chlorines, and I have 6 chlorines, so I am balanced. Okay. So clean that up just a little bit, and there is my answer. Okay, now, next piece. If I have 23 grams of the iron chloride, and I've got 41 grams of the sodium phosphate. So I'm going to write that up here on my reaction. So I have 23 grams of the iron 2 chloride, and I have 41 grams of the sodium phosphate. Now this is just like my sugar and my eggs, where I told you we had 3 cups of sugar and 9 eggs. Here's what I have. It does not mean I'm going to use every bit of it, but that's what I have. Okay? So we want to know what is the limiting reagent. Okay? So in other words, which one is going to make the least number of recipes? Okay? And what they, in this case, they're going to give us what we're going to make. And it tells us we're making sodium chloride. So that's the only thing I'm going to look at. Okay? So what I want to do is I want to determine how many grams iron chloride makes. So I'm going to look at my iron chloride, and I want to know what my grams of iron chloride, how many grams of sodium chloride will that make? Okay, so that's one thing. If I have 1 cup of sugar, or if I have 3 cups of sugar, how many recipes would it make? I also have to do that with eggs. If I had 9 eggs, how many recipes would it make? And so I'm also going to do grams of sodium phosphate. So this is actually 2 problems. And when you're finding your limiting, it's always going to be 2 problems. Grams of sodium phosphate, and I want to know how many grams of sodium chloride it will make. So again, I'm going to do 2 problems, 2 mass-to-mass problems. And we've been doing those, so that should not be a big deal. So let's just go ahead and get started. So we've got 23 grams of the iron chloride. Remember, the next step is molar mass. So 1 mole of iron chloride is how many grams of iron chloride. I'm going to leave that there for now. Then remember, once we have the moles, we do our mole ratio. So that's where I'm going to come up here, and I've got iron chloride and the sodium chloride. Okay? So remember, we are coming from the iron chloride, so that's the 3. And I'm going to the sodium chloride. And again, I don't reduce those. I go ahead and use those right now. So I see, and then that tells me that you know where you're getting your numbers. Okay? Definitely, once you get that, you can go back in and reduce them, but you should leave them in that form, and then if you want to do it 2 to 1. But I don't think it's that big of a deal to just put that in your calculator. Okay, and now we've got moles, but we need grams. So there's our molar mass, again, our last problem. So I want to know what 1 mole of NaCl is how many grams of NaCl. Okay, so we're going to go in and calculate our numbers real quick. So pause if I was you and find your iron chloride and your sodium chloride molar masses. So I went ahead and I figured those numbers out, double check mine, make sure I am right. Now don't forget again let's go in and make sure we've canceled everything. Iron chloride, those are where they're supposed to be. Your moles are where they're supposed to be. Moles of NaCl is where it's supposed to be. So it looks like everything looks good. And so then the next step is to calculate out your values. So this ends up being 21 grams of NaCl. So 23 grams of iron chloride will make 21 grams of sodium chloride. Okay, so now we're going to repeat this same process, but I am going to use the grams of sodium phosphate to grams of sodium chloride. So now I'm going to just start over. 41 grams of Na3PO4. Again, I'm going to change it using molar mass. We'll need to go back in and calculate that molar mass. Again, then we're going to use our mole ratio. Now this time when I go to do my mole ratio, I am going to be using my sodium phosphate and my NaCl. So I again have 6 moles of NaCl for every 2 moles, in this case, of sodium phosphate. Final step, again, go back to mass, your molar mass, and that one doesn't change because I'm still going to sodium chloride. And again, that cancels. Now, go back in and figure out this number for me real quick. But I'm going to go ahead, and this answer ends up being 44 grams of NaCl. Okay? So, when I look at this, then the question says, I'm still not done. The question says, what is the limiting reagent? So, the limiting one is the one that makes the less. Okay? So, in this case, my limiting is going to be that the 23 grams of iron chloride only makes 21 grams of sodium chloride. So my limiting reactant or reagent, whichever one you want to call it, is iron chloride. Okay, so that is the answer. Okay, all that work. Now, next thing we're going to do, we want to know how much excess do I have. So I have 41 grams of sodium phosphate. I definitely don't need all that. So I need to see how much I need. So here's where it kind of becomes a little tricky. You can actually do this several different ways. But the easiest way, I think, is to say, okay, if I have 23 grams of iron chloride that I can use in my recipe, I want to know how many grams, so the question is, how many grams of my sodium phosphate do I need then? Okay, so I'm going to go from grams of iron chloride to grams of sodium phosphate. So again, it's just another mass problem. So I'm going to put those same steps in, those same 3 steps. Okay, so I'm going to go 1 mole of iron chloride, and I have that mass already from up there in the previous problem. My mole ratio this time of the sodium phosphate to the iron chloride is the 2 to 3. Okay, so 2 moles of sodium phosphate to 3 moles of iron chloride. Okay, and now I need to change my sodium phosphate back to mass. So 1 mole of sodium phosphate is how many grams of sodium phosphate. And again, just like before, if you did as I asked you to do, you're going to take that molar mass and you're going to put it right there, and then we can do our calculations. Okay, now double check my numbers because I'm trying to pull this from doing it earlier. This, I believe, is 20 grams of 20 grams of sodium phosphate. So what that means is, just like I did above where I said 23 grams of iron chloride makes 21 grams of sodium chloride, in this case, if I do the recipe, 23 grams of iron chloride only needs 20 grams of sodium phosphate. I have 41 grams. So my excess, is going to be the 41 grams minus the 20 grams that I need. So I have 21 grams of Na3PO4 in excess. And that is your answer there. Okay, so let me pull this all back together. So these problems do take a little bit of work.